we're going to Google bioelectromagnetics. And we're going to click on the Wikipedia page. Bioelectromagnetics, also known as bioelectromagnetism, is a branch of science studying the interaction between electromagnetic fields and biological entities. You are a biological entity. Areas of study include electromagnetic fields produced by living cells, tissues, or organisms. The effects of man-made sources of electromagnetic fields, like mobile phones, and the application of electromagnetic radiation toward therapies for the treatment of various conditions. Now let's go back to Google. And we're going to click on this link. Physical medicine and rehabilitation. Bioelectromagnetism is an interdiscipline that examines the electric, magnetic, and electromagnetic phenomenon in biological systems. It also involves the measurement and stimulation associated with biological tissues. This means that the concept of bioelectromagnetism may be divided in many ways. Here, it is divided into two parts. One is the study of the interaction between electromagnetic fields up to 300 gigahertz and biological systems, such as bioelectromagnetics. The other is the research field that measures the electric and magnetic fields from a bioelectric source. In bioelectromagnetism, electromagnetic fields play an important part in biomedical engineering for two reasons. Electromagnetic fields have a strong potential for medical and therapeutic applications. These applications include the use of pulse magnetic fields, low-frequency electric and magnetic fields, and radio frequency fields. Short-wave and microwave dithermies have already been used. In 1938, Schlieffek in Germany published a book on the use of shortwave therapy in physical medicine. Currently, it is well known that electromagnetic fields can be utilized for promoting bone and wound healing and for the treatment of diseases. The other reason for the importance of low-frequency and radio-frequency electromagnetic fields generated from power lines and cellular telephones is their potential impact on human health. In our daily environment, electromagnetic fields, such as environmental physical entities, including natural geomagnetic fields, human-made electromagnetic fields generated from power lines, and diagnostic and therapeutic units are well recognized. You see, they are already well recognized. Let's scroll down. Table 1. Important events in the history of bioelectromagnetism. In BC, we have therapeutic approach with electric fish. In 1493, we have Paracelsus, medical treatment with magnet as vital stones. 1786, animal electricity from fog experiment. 1831, Faraday, induction law. 1849, medical applications of induction coil. 1864, Maxwell, the electromagnetic field theory. 1891, Tesla, medical application of high-frequency current. In 1925, we had medical application of short wave. 1953, piezoelectricity of bone. 1959, magnetic stimulation of nerves. 1960, human health effects of ELF electric field. 1962, electric stimulation of bone fracture. 1985, magnetic motor cortex stimulation. 2000, human health effect of high-frequency fields. 2003. MRI medical application. At first, epidemiological studies of the potential hazard of electromagnetic fields were put forth to the general public in 1979. During the mid-1990s, however, many research projects focused on clarifying a possible harmful effect of electromagnetic fields. In this chapter, the discussion is divided into two parts. The first part summarizes research results about the biological effects of electromagnetic fields on living systems. The second part gives a short summary of the therapeutic applications of electromagnetic fields. Through the discussion, the concept and importance of bioelectromagnetism are given. I will leave the link in the description for those who would like to read this chapter. But for now, let's keep scrolling. Grounding, earthing as related to electromagnetic hygiene, an integrative review. When looking at biological grounding and other bioelectromagnetic health initiatives, it is necessary to understand that there are a wide variety of confounding factors and variables that can influence results. Identifying and assessing possible synergies between these could enable multi-level interventions to increase their efficacy and viability. Their adoption could also benefit other bioelectromagnetic-based and conventional therapies and infection control operations. Where possible, gold standard randomized double-blind placebo-controlled intervention-based studies should be undertaken to help assess the efficacy of approaches. In particular, the combined effects of different factors should be considered more, as it appears they can create enhanced results beyond those achieved by individual measures. The opportunity now exists for multidisciplinary research to develop healthier, next-generation electronic devices, electromagnetic environments, and bioelectromagnetic treatments that aid biological functioning in clinical settings and everyday life. Correctly undertaken, biological grounding can be an important component of such innovative proactive measures. And let's keep scrolling. Frontiers in liver transplantation. Electrochemotherapy. The theoretical basis of ECT is pulsed electric field technology, PEF. PEFs are a new technology developed in recent decades that span the fields of bioelectromagnetics, microelectronics, and so on. In the 1970s, it was first found that exposing cells to short and strong PEFs would cause changes in the cell membrane. It was first used for in vitro gene transfection, and then for hybriderma production, gene therapy, cell fusion, and electrochemical therapy. Based on the theory of PEF, three kinds of tumor treatment techniques are derived: ECT, irreversible electroporation, and nanosecond pulsed electric field. PEF increases the permeability of the plasma membrane and suitable for chemotherapeutic drugs, such as bleomycin, to enter cells more quickly with the help of PEF. The use of ECT in the treatment of HCC has been reported for a long time. ECT can not only increase the delivery of drugs to target cells, but also effectively reduce the blood supply of tumors through the regulation of electric pulse parameters. The decrease in blood supply slows down the metabolism of the target organs and increases the time for the drug to act on the target cells. Let's keep scrolling. Energy and medicine. The biofield hypothesis. The idea of a vital force is often used to explain therapeutic practices in the West such as mesmerism, magnetic healing, and faith healing. It has been a core aspect of traditional healing practices for millennia and has also been a part of discussion in Western science at least since 1907, when Henry Bergson proposed it as an explanation of why organic molecules could not be synthesized at the time. This thinking held that electricity, the physics and engineering wonder of the time, was somehow connected with this vital force. The modern expression of this idea is often called the biofield hypothesis. As Rubik pointed out, the biofield is a useful construct consistent with bioelectromagnetics and the physics of nonlinear, dynamical, non-equilibrium living systems. For our present discussion, the important aspect of the biofield hypothesis is its dependence on classical electromagnetic fields and forces. Although some aspects of energy medicine may be explained with the biofield, there are at least two aspects of some forms of energy medicine that it does not adequately explain. One is the apparent independence of distance. The other is the apparent instantaneous change of state that can occur. Neither of these can be explained by classical mechanisms. Complementary therapies for the aging patient. The manual therapies. These include myofascial release, craniosacral therapy, Rosen method, Rolfing, Heller work, soma, neuromuscular therapy, osteopathic and chiropractic medicine. The manual therapies involve the use of hands directly on the body/mind surface, thereby stimulating bioelectromagnetic force. Research by Hunt, 1989, Zimmerman in 1990, Eto et al. In 1992, and Rubik in 1995, documents the measure of energy flow from the body and suggests that both mechanical and energy forces stimulate responses from the tissues. Now let's go back to Google. And we're going to click on this link. Bioelectromagnetics. Bioelectromagnetics is a field of study that focuses on the interaction between electric and magnetic fields and the human body. It examines how external electromagnetic fields can impact biological and physiological processes at the molecular, cellular, and physiological systems level. Bioengineering aids to reproductive medicine. Carcinogenic and teratogenic effects of nuclear radiations such as alpha, beta, and gamma rays was recognized very soon after these energies were identified. Thereafter, the damages caused by X-rays was noted. For long, other parts of the electromagnetic spectrum were considered safe unless the intensity levels were so high as to markedly increase the body's temperature. Over the past 2 decades, knowledge in bioelectromagnetics has increased, highlighting the non-thermal effects of electromagnetic fields and the microwave and still lower frequency regions. As a result, procedures such as short-wave diathermy for pelvic inflammatory diseases and working environments like near-portable radio transmitters can no longer be considered as totally free from risks related to the reproductive system. Electric and magnetic fields. Bioelectromagnetics, the study of how electric and magnetic fields interact with the body, is a tremendously exciting field. Electromagnetic fields are all around us. Radio and television signals, cellular telephones, fields from power lines and electrical appliances, radar, and more. They are even within our bodies, in the endogenous fields that keep our hearts beating, brains thinking, and muscles moving. Electromagnetic fields can be used to see inside of us to diagnose illness, sometimes before we even feel it ourselves, in the form of medical imaging. electrocardiography, electroencephalography, and electrophysiological evaluations. They can heal us through therapeutic interventions for cancer, pain control, bone growth, soft tissue repair, electrophysiological stimulation, and more. And they can injure or kill us through lightning strikes, deep electrical burns, and shock. Energy medicine. Focus on non-thermal electromagnetic therapies. In the previous chapter, a range of cutting-edge energy modalities were briefly reviewed. In this chapter, some of the non-thermal bioelectromagnetic treatments, such as microwave therapy, pulsed electromagnetic field therapy, and pulsed signal therapy, will be examined in greater depth. However, here, the non-thermal electromagnetic therapies will be approached as a subfield of energy medicine. Genetic effects of non-ionizing electromagnetic fields. Any effect of EMF has to depend on the energy absorbed by a biological entity and on how the energy is delivered in space and time. Aside from the influences that are not directly related to the experimentation, many factors could influence the outcome of an experiment in bioelectromagnetics research. Frequency, intensity, exposure duration, and the number of exposure episodes can affect the response, and these factors can interact with each other to produce different effects. In addition, in order to understand the biological consequences of EMF exposure, one must know whether the effect is cumulative, whether compensatory responses result, and when homeostasis will break down. A drawback in the interpretation and understanding of experimental data from bioelectromagnetic research is that there is no general accepted mechanism on how EMF affects biological systems. Since the energy level is not sufficient to cause direct breakage of chemical bonds within molecules, the effects are probably indirect and secondary to the other induced chemical changes in the cell. The mechanisms by which EMF causes genetic effects are unknown. This author suspects that biological effects of EMF exposure are caused by multiple, interdependent biological mechanisms. Now let's go back. Here we have BioM. The frontier of bioelectromagnetic science. Just so that we're clear, people go to school and have jobs in the bioelectromagnetic science field. Here they have their membership, their conferences, their journal, and opportunities. Now back to Google. We're going to click on this link. We're here with MDPI, and we're going to read Lessons and Perspectives from a 25-year bioelectromagnetics research program. The question of whether electromagnetic fields from electric power or telecommunication systems can be linked unequivocally to health detriments has occupied scientific research endeavors for nearly half a century. For 25 years, the Bioelectromagnetic Research Group at Swinburne University in Melbourne, Australia, has pursued a series of investigations with relevant endpoints, such as neurophysiological and neuropsychological effects, cell calcium level changes, proliferation, and genotoxic effects. Most have shown no significant changes due to fields. However, in some pilot studies, significant changes were revealed, but in most cases, these were not replicated in follow-up studies. This highlights a feature of research area. Generally, the unambiguous identification of small changes in noisy data, where the understanding of possible interaction mechanisms is lacking. On the other hand, Mathematical modeling studies, particularly with respect to fields near metallic implants, in workers exposed to fields in harsh environmental conditions and at very high frequencies, terahertz, continue to add to the expanding knowledge database on the characteristics of the complex electromagnetic environment we live in today. The key words here are electromagnetic fields, radio frequency fields, magnetic fields, and tissue electric properties.